Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. Some of you have asked, what does this line actually do? So here we have a return type. So list models.task. So as you can see, it is using a generic. So this list item over here can take in a data type. So this models.task is actually lives in here. So we got models.task. So this class is a data type and it has the following properties, as you can see here. So if we go back to here, that's just a return type over here. And then this is what is known as the method name. So here, what this method does is it simply returns a variable called task. So where is that variable defined? So up here we have a variable that is a private variable to this class. It is of the following data type, which is a list of tasks, and that's what it's called, and this is how it's initiated. So this variable over here, tasks, basically is what we are returning down here. And you can see this is the lambda arrow. So normally what you would do is, so you just want to return a simple statement or something, then you don't need to write out the function fully. You can just use equal sign and the right arrow and then put in what you want it to do. This code over here needs to be a one-liner. It basically needs to fit onto one line, not go over multiple lines, ideally. So here, if you were to not do that, this is what it would look like. So here, as you can see, this class basically has a function. So this is the alternative syntax, this function over here. And all this function does is basically return task, which is basically doing the same thing as here, because this return tasks and this return tasks. Remember, task is a variable that's declared here up there, and that's all within this task service class. So this is a bit of a shorthand syntax. It is basically equivalent to tasks2 here, get or tasks2, and it returns a task. This also returns a task, and this variable is actually then used here because this is being used when we have this service class and we're calling this method. All it returns is a variable for the tasks, and that variable actually is just the tasks here. And once those are returned, then we are just looping through them and then doing a write line, and we're using the task variable here is task completed, task ID, task title. So as you can see, that's all this line does. This line is often referred to as expression-bodied method because this is a method and its body is actually just an expression, a small piece of code that doesn't need to expand multiple lines. So as you can see, this would have been a waste of time because we had to write a return statement, we had to declare the method like this, we had to add the curly braces here, while here the syntax is much more simpler. All you do is just use the lambda equals right arrow here, and then you just say what you want to return, so you don't have to do this. So I hope this explains what this line is. This is referred to as expression-bodied method, and you may see this commonly used within C#. There are two ways to create a new instance of something. One way is this way, which is where you just use the new keyword and open parentheses, close parentheses, and the other method is using the classic syntax. This syntax was introduced in C#9, which means that the compiler will be able to figure out, based on what's on the left-hand side, it will work out what it needs on the right-hand side. So here we are declaring a variable called tasks2 of this type, models.task. So this is a list, and normally you would do this. You would use the new keyword and then basically repeat what's over here, which is list models task and list model tasks. But starting with C#9 and onwards, you will often see this syntax being used. And this is just a shorter way of doing all this because in essence, the compiler is able to figure out everything based on the left-hand side of the equal sign. So I hope this explains why you see statements like this versus statements like this, and both of them are equal. You only need to use the OR method if the compiler is unable to figure out what type it is. C# new keyword can be used like this, where you are specifying the class here, and that's the variable name, and then you've got the curly braces here giving the two properties that this object needs. So if we have a look at the person class over here, you can see this is the person class and it's got two properties, name and age, and it also has this method called introduce that simply prints out some information over here from the variables. So as you can see here, when you use the new keyword, we are using the targeted type. So that means the compiler is able to figure out that the new object that you're asking for is of the person class. In the old style, we used to specify the object on both sides. So this is where we want to store the variable, and this is the object that we want to create. So you can see the person class with the following properties. So you can see in one, it is shorter syntax, while in the other, you have to type in the class name again. But if you use the var keyword, you cannot get away with not specifying the class name after the new keyword, because there is no way for C# compiler to know what var actually represents for this variable here. So you cannot, for example, do this where you are just specifying var person, that's just the variable name, and then new, and then just some properties. Compiler cannot figure it out. So you have to use the class name here in order for that to work with the var keyword. So I hope this clarifies the target type. You don't have to use the class name and the old style syntax, which is still very much needed if you want to use the var keyword here and don't want to specify the data type. So if I run this program, so you can see person and person2, so that's person and person2, both of them will give the exact same output, and the program works as expected. And it also works for person3. So if I change that to person3, and if I run this again, then you can see both of them give the same output. But just remember, if you're using the var keyword, you need to specify the class over here with the new keyword as mentioned. In C#, let's try and access an API. So here, this is an example API that's fully open that anyone can query. So if I show you that in a website, so as you can see, that's the URL, and all it has is a JSON data format. And what JSON data format is just like CSV, but it's got a key and a value. The key and value pairs. That's what JSON data format is. And you can see each item is separated by a comma and these curly braces. So that's, think of it as one object in a class. So if you have a class of posts, then it will have the following fields: user ID, ID, title, body. And then this is the next item over here, and then so on. And all of them are surrounded by the square brackets here, and that's what a JSON format is. So we have data for 100 posts within here, as you can see over here. I've got the Firefox browser, which actually shows you this in a nice format. So you can see the user ID, ID of the post, and then this is the title and the body. But this is what it looks like in raw. So in C#, how do you actually work with this data? So here, as you can see, we are importing in a few namespaces. These are all built into C#, so there is no extra installation required. The HTTP client here is basically coming from this namespace there, and what we're going to do is, using the client we have here, we are just gonna get the URL, which is defined here, and then we will get a response back. And then this code here just ensures the response we get is a success status. So that means there are no errors that have occurred. And then we are going to read and parse the JSON format. So what we're going to do is we are going to await for that data to come back using the await keyword. And then we are going to read that data and store it within the JSON string over here. And then we're going to map it against a post variable using the post class. And you can see here, this JSON serializer actually comes from text.json. And what it will do is it will deserialize. So basically convert the JSON data that we have into a class data object called post. So what does the post object look like? Well, you won't be surprised. This is what we've called it. You can call it anything that you want, but these fields here, like ID, title, and body, they need to match exactly as the field's name here. So you got user ID, ID, title, body. Even the casing needs to match. So if this is lowercase body and this is a lowercase ID, then that needs to match over here. Otherwise, it won't work. So what it will do is it will map those exact items from this JSON into the post class object that it's going to create. And it will do that automatically because the field name match. We are going to loop through that and print out the post ID and the post title. Remember, we're now using the post variable here, which will basically represent a single post in this class over here. And then there is any error, then we'll simply capture the error here and say something went wrong. So this is, in a nutshell, a quick walkthrough of how to access an API in JSON using C#. There are multiple ways of converting char data type over here and joining them together. One of the easiest one you could do is by using an empty string. So here we are declaring a variable of string type called result using the plus operator here to join C1 and C2. Now this empty string is really important because without it, this will not work and will give you errors. So if I remove that, we can see we're now getting an error which says that it cannot convert int to a string. So you must use an empty string in order for this to work. And then the other alternative way of doing it is using this string class here and its static method called join. What this will do is it will join your char date type over here, but you can also have a literal, anything in single quotes is char date type. And you can see here, I can also include string. So what this will do is it will join C1, C2, the literal 2 and a string hello together in one. And notice here, this empty string, that's basically the character separating all these. So if you leave it at empty, then it won't have separation character over here. And of course, with the advantage of string.join is it can also take in arrays. So here we've got array of char date type. So you can see it's the word hello separated by a single character. Notice again, single quotes for char date type. And here what we're doing is we are just bringing in the entire array and this will join them together. Again, your separated character could be an empty space or anything that you want. Another alternative method is you can just use the constructor for the string class and just pass it your char variable here. So again, this is an array for these characters and you can see it will convert them to a string, then join them together. So if I run this program, and as you can see over here, so let's go through the results. So for this one over here, you can see it's printed AB, and then here for this one, we've got hello, and you can see down here, AB to hello is what we got because it's disjoint AB and the letter 2 and hello. And then you can see our array. So this again over here is being printed over here. And then you can finally see we are using the constructor method here and it's just taking in array of characters. And you can see the output is hello 2, which is what we had here. So there are different ways of doing this. And you can see this one is one of the easiest ones to use for quick joining one or two variables. This one is quite good if you have multiple variables and you want to separate a character between them. So for example, I could have underscore over here, and if I run this program again, and you can see here the output is we now have an underscore as the separator between all the data over here. So with this method you would kind of struggle and it would make your code harder to read, but this one is easier to read. And of course with the join one you can take in arrays, and of course you can use a constructor method over here which just basically takes your characters, but notice here you can't add a separator between each character over here. So depending on the situation you're using, the most flexible one is probably string.join method. A very important keyword in C# is this async. So let's try and understand what this is doing. Let's say you have a button, and this button, when you click it, what it will do is it'll go and change the label content to waiting and then do some tasks. So in this instance, what we're doing is we just want to delay our code for 10 seconds and then display a done message in the label. This is bad because what it will do is it will freeze up your program. So if I demonstrate this, so if I run this program over here, and as you can see here, if I click this button over here, notice that it's frozen. It hasn't changed the label contents. And when I hover over it, you can see that it seems to be so. And now it's displayed the message done. So if I click on that again, you can see I can't even move the program window. So when I try and click this or maximize it, I cannot maximize it. But if there you go, now I can move it. So this is the difference. So how can we make this responsive? So it's all the magic of this async keyword. Now this async keyword, you add it after the private keyword in this instance, or it could be a public keyword. So you add it before the function name, and notice here that it's returning void because normally events from buttons do not return anything. So we just return void here. And then notice here we use the await keyword and we are again using task.delay. The user interface will still work properly. This label will still get changed and then label would get changed here as well. So if I now just change the method name here, change that to 2 and remove the 2 here so that this one becomes the method that it will execute. So if I run this, now notice the difference in the behavior. So you can see I can move it, but if I click this button over here, notice when I move my mouse over this, the color changes. But now as soon as I click this, will all this still work? Will it let me move the program? So you see the label text, if I click there, it changes to waiting. And notice how I can move the window, I can maximize it. I can also hover over the button and it still highlights it. And now it's printed a done message. That's the advantage of using async keyword here. This is just by convention. This is something you just have to use. And then you go to use the await keyword. And then what this will do is it won't block your user interface by using the await keyword, and then it will execute whatever task that you want or method that you want. In this instance, we just use executing the delay method, and all it does is just delays the program for 10 seconds and then it prints a message. But the behavior difference is the very first time it goes and executes this, it updates the label to waiting. Whereas in this example, it didn't actually change the label content to waiting. It just left it as it is. It got stuck. But using the async keyword and the await keyword, it didn't get stuck. So remember, this is just by convention. You have to do this, and void is the return type for this. So that's fine. That's same as before. And then you just use the await keyword. So 2 simple keywords to make your program responsive. Let's continue exploring the async keyword and do something very interesting. So the main method will execute and print out a counter, but a function should be executed in the background to do some processing. So how do you do that in C#? So here, as you can see, by standard, we have to use the async keyword to mark our main method here. So this will be the entry point into the program. Async is always needed, and then you've got the return type as task. Again, this is needed as standard. So here you can see something interesting. Task. Task is a class type. So if I hover over, you can see it comes from system threading tasks and task. And this is a variable name. And what it's doing is we are just getting it to execute a function. What is this function? Do background work. So if we go down here, this is what the function looks like. Notice that it also has async and task. Remember, you use the return type as task if your program doesn't return any data type. So here, as you can see, it doesn't actually return anything. What it does is it does some processing. In this instance, it's just writing out lines to the console, but it doesn't have a return type. So that's why you use the keyword task here. And then you can see, so while that is executing, so this will have a delay of 10 seconds. Then we start this counter, and this counter is basically going to check if the background task variable here, which is of task class type, and it has a property code is completed. As long as this is false, then what we want it to do is loop and do print out the counter, and then sleep, and then print out the counter again. And then continue doing this until this task has finished executing. So this task is basically a function, and this function basically has a delay. It has a right line at the beginning to say starting the background task and then finishing the background task. So if I run this program, and as you can see here, the counters keep increasing, and then eventually the 10 seconds will pass, and there you go. You can see that finished background task and background task completed has been printed. So what it did was finish the background task is here. So the function has finished, and then you have after our loop here, we've got the line printed to say background task completed. So the loop, basically this condition is completed, becomes true because it's now complete, and the not equal to indicator here doesn't really apply. So it will then say, yes, is completed is now true. So now it will execute this line over here. So it's quite simple. So as you can see, all you had to do was use the keyword async and task. Task is just the return type. If your program doesn't return anything, then you can just by convention use the word task here and async, and that's all that it takes. Notice I am using the await here because what I will do is wait for these 10 seconds to pass and then print the line. So it's waiting for this to finish, and then this will get printed. But notice here, this is different. This actually kicks off the task in the background, and it just, in this instance, it's just executing this function here, which will do its bit and do whatever that it needs to do, while the main thread is actually just going to loop through and print a counter. So here the counter was working here, and then once our function finished, it said finish the background task and printed this line. And you can see here, this is when the background task started. So you can see here that starting background task, that's very happy. So I hope you found this useful around async and how you can use it to run a background task. So using the async keyword, how do you return something from a function? So here, what we're doing is we are calling this background function, which is gonna be initiated from your main method. And what we want to do is we want to return a string. It could be any return type, but in this instance, let's assume it's a string. So if we have a look at the do background work sync method, so again, that's the method, and over here is the definition. So as you can see that it returns hello. So as you can see here, we bought async keyword. This is standard. If you want anything to run in the background, you have to use async, and then task. And you can see here, that's the return type, but task actually allows for a string as an output as well. So when we return this as hello, this gets passed back over here into this background task variable. If we go down here, we can see later on we are getting the results of that task by using its name and the await keyword. So there are a couple of things that are very important. You cannot do this without the await keyword. So as you can see, you will get error. So this name matches, so this name over here matches name over here. So that's the variable. And then you're storing the result within here. And this is string variable. Notice here that you cannot just get results out here because this actually is a promise. And all it does is it basically kicks off this task and then remembers because that it kicked off their task. The actual output of it will appear here by using the await keyword. So if I run this over here, and you can see that the counter is increasing over here, and eventually it's going to stop, and there you go. And as you can see here, it's stopped, and we've got the background task is finished, and the result from the background is printed. So that's printed by this line over here, which takes the results, and the results comes from here, and we use the await keyword to pull back the result. So the await keyword basically waits for that task to finish. Once it has finished, whatever the output of that function is, it gets stored here. So you can, again, if I try, it cannot, for example, return 1 in here now because it's saying it's expecting that type int. So what you can do is, if you want int to be the output, so you can just say int here, and as you can see here, we get the result back over here. So if I run this task again, now notice that we get the error. This is because we haven't changed the variable here, so we're going to change that to int. And notice over here as well that we need to change this to int because we're returning an int type. And then if I run this again, and as you can see, our code is running over here, and we'll let this finish. It has now finished, and we've got the output printed here. So we changed it from a string over here to an int, and you can see we're returning an int, and then you have to change that this actually returns an int as well. And then when we use the result here, notice that this needs to be an int as well, and then you can print the results here. So I hope this clarifies how to run a background task, get a value out from that task as shown here using the await keyword and the variable name that we declared, and then this is the output that we get, which is return 1. Let's try and understand class attributes for decorators. So as you can see here, this is a program that I have. I will basically read an API endpoint that outputs information in JSON format, and this is what the format looks like. So you can see here, if I go to raw data, I have the following JSON format. It's got user ID, it's got an ID, a title, and a body. And then you can see each element is separated by these curly braces and a comma, and everything is wrapped in these square brackets. And this is what JSON format is. And in Firefox, you can actually see JSON format in a nice layout like this. So you can see these are the fields that we've got, and that's the title, and that's the body. So let's try and understand how do we map this to our class in C#, and how do we use class attributes. So here I have a class that has the same properties as the JSON file, except this field. You notice this one is called unique post ID, and the rest of the fields are the same. So if we have a look at our JSON file, and you can see here that the second field is called ID rather than unique post ID we have in C#. So how do we map this against the JSON file? So here, this is our endpoint URL. We are going to create a HTTP client. Each response would be stored here. We would then read the content, and that would be the JSON output, and then we deserialize it. And this is where the mapping actually happens, JSON to post class mapping. So in order for, if I just run this, so you can see the output. So at the minute, you will see that for the post ID, which we are trying to print, it just prints 0, 0, 0 all the way across to the post that we have. So clearly there is something wrong. The ID field is not being mapped correctly. So what you do is you add an attribute to this class here. So this is the attribute that you would add to your class. And as you can see here, it's a JSON property name. And what we said is this unique post ID should actually map to ID over here. So this is what it appears in the JSON file, and this is what it appears in our class. So we want them both to be linked. And now if I run my program, what you will see is the mapping happens correctly, and all the ID numbers, as you can see here, appear correctly, and there is no longer any mapping issue. So just by simply using the JSON property name and adding that other decorator or an attribute to our property here in the class post, we can easily map our items when it deserializes the JSON text file that we get about. So I hope this explains about custom attributes you can add to your classes, including to your methods, to your properties, and how they behave. So in this instance, we used an attribute JSON property name to allow our mapping against the JSON file here, because we have hold things differently. So we're just resolving the mapping conflict by using an attribute over here.